My name is Gabriel Cardona, and I am developer evangelist at Ava Labs. And today I'm going to be talking about an introduction to Avalanche JS, which is the Avalanche platform's JavaScript library that I help maintain with a team of amazing developers. So as I mentioned, my name is Gabriel Cardona, and I'm the head of the developer relations squad at Ava Labs. And along with Jovitsa and Yulin and Raj and Julian and Lucian, it is our task to help on-ramp developers into the Avalanche ecosystem. And we have three different tasks that we maintain. We help maintain Avalanche JS. We also do partner integrations, so we spend a big part of our time interfacing with teams and companies over Slack and Telegram, helping them understand our tech stack, and then helping them understand how to best interface their technology with our technology. And then also I spend a lot of time going to conferences and meetups and hackathons and conventions, very similar to this, explaining how Avalanche works and hoping to inspire people to build on Avalanche. So hopefully by the end of this today, after seeing all the different presentations and all the exciting stuff that's happening in the ecosystem, you too will be very excited to build on Avalanche. And so Avalanche is growing at an incredibly fast clip. These are some stats that I pulled down based on our Keychain just yesterday before I flew out here from San Francisco. You can see up here in the top right, we just had a big milestone of crossing 100 million cumulative transactions, and that was a really, really big milestone for us, and we're already now at about 165. I think it's growing about 1.5 million transactions a day, so that's very, very exciting. Just this last week, we crossed 3 million cumulative transactions, and then we also now have close to 200,000 unique contracts deployed by about 30,000 unique developers. So this is just our Keychain. Of course, Avalanche is a network of many different blockchains and subnets. These are stats that are just coming from our Keychain because our Keychain is where most of the action is happening. But I think whenever you see stats like this and see numbers like this, and I believe there were 700 developers that had registered to attend this event, although I'm not entirely sure everybody's going to make it. Avalanche is just growing really quick, and this is just a really unique opportunity to have an oversized impact with your work on a network which is going to have an impact and resonate for generations, is what I believe. We're building the Internet of Finance, and in the same way that the original people who created the DARPANET in the late 60s and the TCP/IP stack in the early 70s, their work is arguably having a greater impact now than ever, and it's been 50 years since that work happened. We are building the Internet of Finance, and our work is definitely going to have an impact for generations. So if you're a developer and you're looking for an ecosystem where you can have an oversized impact with your work, I suggest checking out Avalanche. All right, so now I have my notes here, so I'm going to be going back and forth. Let's talk about what is Avalanche JS. So as I mentioned, Avalanche JS is the JavaScript library for interfacing with the Avalanche platform, and it is built using TypeScript. So it's very, very modern, and it's very, very idiomatic. And really quickly, I'm a huge, huge advocate of TypeScript. If you're working with web technologies, so if you're doing any JavaScript basically in your day-to-day workflow, and if you're doing software, somewhere in your workflow you're likely using some JavaScript, I really, really suggest that you take the afternoon or so to on-ramp into the TypeScript workflow. The overhead isn't that huge, and the payoff is really, really big. It will help you think about your abstractions much, much more clearly, and it will basically give you the confidence whenever you're working with value-bearing assets, which is what we're doing in crypto. And so definitely, I really recommend checking out TypeScript if you haven't already. I suspect most people in here are using it. Every single time in my career when I have turned a JavaScript file into a TypeScript file, we have immediately found bugs in the code. And so I think it's nearly a universal experience. I myself have experienced it every single time I've converted JavaScript to TypeScript. So I just really want to quickly plug TypeScript. If you're not yet using it, you absolutely should be. So Avalanche JS is intended to support both the browser as well as Node.js. So you can use it in a React native app, like on your phone. You could use it in an Angular web app. You could use it in a command line utility with Node.js. Avalanche JS basically allows you to issue commands and then issue them to an Avalanche full node, which we're going to talk about here in a second. So Avalanche JS has three areas of functionality. There's the Json Rpc, it does transaction serializations, and then it has a keychain, which is different than the full node's keystore, and we're going to dig into each of those right now. So the Json Rpc is the first area of functionality, and a Json Rpc is a remote procedure call which is encoded in JSON, It's very similar to an XML RPC protocol. It defines only a few data types and commands and allows for notifications, which is data sent to the server that does not require a response, and for multiple calls to be sent to the server that can be answered asynchronously. And currently, again, when I checked the stats yesterday before I left San Francisco, Avalanche is currently at 1,576 full block and vertex producing validators or nodes, and each one of these nodes can optionally enable these set of API endpoints which developers can then interface with and consume over Json Rpc using Avalanche JS. And so these are the different remote procedure calls which are available. First, we have the admin API. So this API can be used for measuring node health and debugging. And note that it's disabled by default for security reasons. So you'll need to pass in the API-admin enabled equals true flag. Whenever you fire up an Avalanche Go full node, obviously you can pass in a bunch of different flags. So some of these RPCs are disabled by default, and you need to enable them for security reasons. For example, some things you can do with the admin API. We have these 32-byte identifiers for like subnet ID and chain ID, and they're CB58 encoded. It's like a base 58 encoding with a checksum. And the strings are, relatively not human readable, and it's not something you would, share with somebody by speaking the characters. So you can actually alias these really awkward human readable strings into something that's much more easily shareable. So today, if you've used our RPC and you hit like /C instead of /ECT/BC/C, the /C is the alias, when really the blockchain has some big, gnarly, not very readable string. You can alias it to something that's much more readable. There's also the auth API. So when you run a node, you can require that API calls have an authorization token attached to them. And this API manages the creation and revocation of authorization tokens. An authorization token provides access to one or more API endpoints, and this is useful for delegating access to node APIs. It's important to remember that these tokens expire after 12 hours. And so, as I mentioned, you can manually revocate them if you want to prior to 12 hours, but every single 12 hours, they will automatically revocate and you'll need to recreate them. So if you want to lock down all of these endpoints by a token that needs to be passed with each request and response, you need to be aware that every single 12 hours you'll have to create a fresh token. We have the AVM API. So in our world, and we're going to talk about this a little bit in depth later, but we have this idea of virtual machines, and then they can be instantiated into blockchains. So here you can see it says the AVM API, and it maps to the X chain. The Avalanche virtual machine is the virtual machine, but whenever you instantiate it, it's called the X chain. So on our primary subnet, we have three blockchains: the X chain, the C chain, and the P chain, all of which are instances of the corresponding virtual machines. And the X chain is Avalanche's native platform for creating and trading assets. And it's an instance of the Avalanche virtual machine, as I mentioned. And this API allows clients to create and trade assets on the X chain and other instances of the AVM. So at the very end, if I have time, I'm going to demo how to spin up your own subnet, instantiate an instance of the AVM onto your subnet, and then to add 5 subnet validators. And so this API would allow you to communicate with our X chain as well as communicate with the instance of the AVM on your subnet, which is going to have its own Json Rpc. We have the Evm API, which, as I mentioned, the C chain, which stands for contract chain, is an instance of the EVM. It has 100% backwards compatibility with existing developer tooling in Ethereum ecosystem. So if you're using Remix or MetaMask or Truffle or Hardhat or any of those tools, Web3.js, Ethers.js, it goes on and on and on. They're supported 100% out of the box with our C chain, which is one of the reasons you saw all of those crazy stats in the beginning for our C chain. All of these applications which were suffering from either being too slow or too expensive on other EVM instances and other EVM networks, we're able to basically just add the C chain as another network ID and deploy their smart contract to our C chain with very, very minimal changes. And that's one of the reasons our C chain is absolutely blown up. We also have the health API. So this API is used for measuring your node's health. And the nodes run a set of health checks every single 30 seconds, including a health check for every single chain which that particular node is validating, not just the 3 chains on our primary subnet, but anything on your subnets as well. And then this method returns the last set of health checks based on every 30 seconds. We have the index API. So Avalanche Go can be configured to run with an indexer, and that is it saves or it indexes every single container. So these are vertexes, these are blocks, these are transactions, every single thing that it accepts on either the X chain, the P chain, or the C chain. And if you run Avalanche Go with the flag index enabled equals true, then you can use this index API to get the last accepted container, which as I mentioned is a vertex or a block, and then you can traverse all the way back to the very genesis block and recreate the entire data structure using AvalancheJS over these Json Rpc calls. We have a Keystore API. So every node has a built-in key store, and clients can create users on this key store, and it acts as identities to be used when interfacing with blockchains. So this key store exists at the node level, and if you create users on a node, they exist only on that node, but they can be exported and then imported into other nodes. So you can fire up your full node, you can create users on there. It has its own key store. It's their SecP256K1 keys on ECDSA key pairs, and then you can actually export them and import them into another node if you want. We actually consider that a bit of an anti-pattern, which is one of the reasons AvalancheJS has a key store functionality, which is I'm going to talk about here in a second. But if you just want to use the full node, you can do that. You don't have to use AvalancheJS. But you end up storing your keys on a full node out on the public web, and it's a little bit of an anti-pattern. We also have the metrics API. So this API allows clients to get statistics about a node's health and performance. We have the platform API. So the P chain is what maintains Avalanche's validator set and handles blockchain creation. So this is like our administration chain. If you want to add validators, add delegators, create a subnet, launch a virtual machine as a blockchain on a subnet, add subnet delegators, do any of that kind of stuff, you do it over the P chain, which is an instance of the platform Evm Api. And then we have the socket API, which is just an API for getting real-time WebSocket data. And so each one of these endpoints can be queried using HTTP. You can use something like a Postman collection. My team maintains our Postman collection. It's been pretty popular. But you can also use AvalancheJS. So every single one of these endpoints has been implemented as a JavaScript class. You can create an instance of these classes, and then each one of these sub-endpoints for these parent endpoints is just a method on that class, and you can call the method, pass in arguments or parameters, and then it'll use HTTP. We use the Axios library. It'll use HTTP to ultimately query the JSON remote procedure call and then return you the data. Okay, so next we want to talk about transaction serializations. I want to give a brief aside and talk about two very powerful paradigms that are happening on Avalanche, because they're going to be critical for us to have the next part of this conversation. So the first is subnets and the second is virtual machines. So subnets are dynamic sets of validators working together to come into agreement on the state of a set of blockchains. And in this particular case, a blockchain is an instance of a virtual machine, as I mentioned. And then a virtual machine is the application level logic of your blockchain. And a good way to think about a virtual machine is it's very much like a class in object-oriented programming. So you have a class, which is a description of an object, and then you can instantiate this class into as many different objects as you want. Each one of those objects, even though they derive from a common class, they're all separate and unique individual objects, and they're not really related to each other than having derived from the same class. A virtual machine is the application level description of the blockchain that you want to create, and then a blockchain is an instance of that virtual machine. And you can instantiate a virtual machine as many times as you want into as many different blockchains as you want, and you can even instantiate it into multiple blockchains on the same subnet. Although we suggest that you only run one virtual machine per subnet. That way you can be confident that your virtual machine or your blockchain will get the best throughput and time to finality as possible. But obviously it's possible to run more than one virtual machine on a subnet, because we run our three virtual machines on our primary subnet, the X chain, the P chain, and the C chain. But just as a best practice, we recommend that you only do one at a time. And similar to object-oriented programming, each one of these blockchain is a unique and instant separate identity of a blockchain, which they're only related by having derived from a common virtual machine. So technically speaking, a virtual machine is a state machine. It specifies a blockchain state, a state transition function, transactions, and then an API through which users can interact with your blockchain, basically the Json Rpc. And every single blockchain on Avalanche is an instance of a virtual machine, and firing off a transaction will trigger the state transition function in your virtual machine or your blockchain. So that's why, by default, each one of the VMs on Avalanche have a series of transactions that when you post them to the full node will kick off a state transition function in the virtual machine. So very briefly, we'll talk about the ones that are on the primary subnet. The Avalanche virtual machine, or the X-chain, has the base transaction, which is used for sending AVAX back and forth, as well as for sending assets which you create yourself. So you can create variable and fixed cap assets on Avalanche, and you use the base transaction to basically send them back and forth. Again, similar to object-oriented programming, each one of these subsequent transactions inherits all of the functionality of the base transaction. So the create asset transaction, for example, does everything that the base transaction does. You can use it to send assets back and forth. You can use it to send AVAX back and forth. But you also use it to create an asset. So when you call create asset transaction, you pass in a name, a ticker symbol, an initial state. So for example, you would say these addresses are getting so much of this different asset. And then you can also create a minting token. So the difference between a variable and a fixed cap asset is whether or not you want to be able to mint more of that asset in the future. So if you just want there to be only so much of this asset ever in all existence, you just set that up when you call the create asset transaction. If in the future you want to be able to mint more of this asset, you'll create a mint token and assign it to one address or two addresses. You can do multi-sig, you can do threshold signatures and time lock and all kinds of funky stuff. We have an operation transaction, which again extends a base transaction and gets all of its functionality. And then you can use an operation transaction to actually mint more of an asset. You can also create NFTs, and then you can send NFTs as well as mint NFTs. And then we have the import and the export transactions. So as I mentioned, Avalanche is a network of many different blockchains. So we have built in at the protocol level the ability to move assets, the rails, to move assets back and forth between different blockchains. And the reason this is important is because there's already network effects that you'll see on a single chain, like you see network effects on Bitcoin, you see network effects on Ethereum. But what's really cool about Avalanche is we have compound network effects. So the network effects that are happening on one blockchain can actually amplify network effects that are happening on another blockchain and get compound network effects, and that's pretty cool. Next is the EVM. So this is the Ethereum virtual machine. As I mentioned, it has 100% backwards compatibility with existing developer tooling. So everything you know about the EVM would stand true for this virtual machine. There are just a couple of different transactions that we've grafted on to make it more idiomatic and compatible with our existing API, and that's the import and the export transaction. So you can actually swap tokens between the P chain and the C chain and the X chain and back and forth between all of them. And then as I mentioned, the platform virtual machine, the P chain is the instance of it on our default subnet. This is really our administration chain. So you can create a subnet. So whenever you create a subnet, you create what's called a control threshold signature. So you can pass in an array of addresses. Let's say you pass in 3 addresses, and then you pass in a threshold. Let's say you pass in the number 2. So then you're saying, if anybody wants to make any changes to this subnet in the future, if you want to instantiate any virtual machines as blockchains, if you want to add any subnet validators, 2 out of these 3 addresses need to sign a control threshold signature in order for that to happen. Next, we have the add validator transaction. So as I mentioned in a previous slide, as of yesterday, we have 1,576 full block and vertex producing nodes that are validating the Avalanche network. And you have to currently stake 2,000 AVAX in order to make your full node a validating node. And 2,000 AVAX is relatively a lot of money. We realize that. And so that number will definitely be going down in the future. It's on our roadmap to take that number down. It's currently 2,000, but it won't always be 2,000. In theory, Avalanche Consensus can have millions of validators. So today, when we say we have 1,500, that seems like a lot. But our intention is for you to be able to run Avalanche on an IoT device, to run it on a PC, on a Macintosh, on a VPS droplet on the cloud, on your phone. We predict there's going to be tens of thousands, hundreds of thousands, millions of validators in the far future. So that 2,000 required AVAX to stake will definitely be going down in the future. We have the add subnet validator transaction. So whenever you spin up your node as a validator, you can validate for up to 1 year. So when you spin up a subnet validator, you actually have to create a start and an end time, which is a subset of that 1 year. And we're going to show that here in a second. As I mentioned at the end, if I have time, I'm going to demo spinning up your own subnet, launching an instance of the AVM on it, and then adding 5 subnet validators. So you'll see what that looks like here in a second. We also have the add delegator transaction. So a validator is a full block and vertex producing node, but you can actually delegate, which is add your weight. Which you could, I think right now it's not that much. I believe it's like 25 AVOX, and that number will be going down as well. You can delegate your stake to an existing validator, and that will increase their weight, which increases their statistic probability of being sampled every single round when a new block or a new vertex is created. So that's what you do when you delegate. We have the create chain transaction, which, as I mentioned, once you spin up your own subnet, you can then instantiate a virtual machine as a blockchain. We're going to see what that looks like at the end of this. And then lastly, we have the import and the export transaction, which, as I mentioned, are rails for you to move assets back and forth between the X chain and the P chain and the C chain. Soon you'll be able to do this between different subnets as well. We're going to have cross subnet transfers built into our protocol. Okay, so the last thing that we have, the last bit of functionality which AvalancheJS covers is the keychain. So as I mentioned earlier, Avalanche Go has a full key store, and that enables you to create users with key pairs to sign transactions all via the full node's key store. The problem is this requires you to store your keys on a full node, and the full node is likely going to be accessible over the public web, so you have to worry about malicious hackers. So we consider this an anti-pattern. And to solve this problem, we've implemented a keychain in AvalancheJS, and it can actually serialize all the different transaction types that I just talked about, and then sign them to send to a full node to kick off the state transition function. And the keys never have to leave your machine. That's the main point I want to get across here. So you can even leverage tools like a ledger hardware wallet for greater security. Again, if you have a non-trivial amount of crypto, the best place to store it is in something like a ledger hardware wallet, and then you can even use these ledger hardware wallets to sign transactions with AvalancheJS. So that's the absolute best setup, is that you create these transactions with AvalancheJS, you then sign them with a ledger, and then you then post them to the full node. The AvalancheJS keychain supports the SecP 256K1 curve on ECDSA key pairs, which is very much in line with what's happening on all 3 of the primary, all 3 of the virtual machines which are running on our primary subnet. And so very quickly, I want to talk about, I already talked about the different transactions that are available to trigger the different virtual machines state transition functions, but there's actually a couple more data types that I want to talk about. So we have different outputs, we have inputs, and then we have operations. So with regards to outputs, we have 4 different types of outputs. Pardon me, my nose is running a little bit. We have the SecP 256K1 transfer output. So this is useful for transferring AVOX back and forth, as I mentioned, as well as you can issue your own variable and fixed cap SecP assets on our X chain. This is useful for transferring those. We have the SecP mint output. So as you might imagine, if you want to mint more of this custom variable fixed cap asset in the future, you have to issue a mint output during the genesis of that, the create asset transaction, and then you can use this to mint more. We also have the NFT transfer output and the NFT mint output. As you might imagine, these are useful for transferring NFTs and for minting more NFTs. It's worth noting that the NFTs that you can issue on the X chain are not compatible with ERC 721 or ERC 1155. They are more akin to like a collectible type paradigm, but you can in fact issue NFTs on our X chain, and they're very inexpensive to mint and then transfer. There's currently only one type of input. It's our SecP 256K1 transfer input, which I'm going to show you a demo of here at the very end. But you use this whenever you create an output. It's an unspent transaction output, UTXO, if you're used to this from like the Bitcoin model. Then when you consume this UTXO, you have to actually create a corresponding input that you then sign with AvalancheJS, and it allows you to transfer the assets. And then we have what are known as operations. If you remember, the third transaction type on the X chain is an operation transaction. And we have mint operations, so this is for minting SecP assets. We have an NFT mint operation, and we also have an NFT transfer operation. So what's really cool, as I mentioned, the create asset transaction, the operation transaction, the input transaction, the the import and the export transactions, they all extend the base transaction. So in AvalancheJS, you can actually create a transaction where you can move AVAX back and forth, you can move a SecP asset back and forth, you can move NFTs back and forth, you can issue a new SecP asset, you can issue a new NFT, you can mint new SecP assets, you can mint new NFT assets, all in one single transaction. So it's pretty advanced what you can do once you kind of understand how all of these different components fit together. It's kind of like a multi-dimensional Lego kit, and once you understand how it works, you can go pretty far with it. So I wanted to really quickly give a demo of, or I wanted to show some code before I give this demo of what it looks like to do multi-sig on AvalancheJS, because multi-sig is a very, very powerful paradigm which allows you to basically prevent one single person from having the ability to send funds. And this is very common, and I think it will be much more common in the future in like a corporate responsibility type environment where you want to, for example, divide some funds between, let's say, 3 different C-level execs, and you want to have at least 2 of them have to agree before any of the funds can move. This creates corporate responsibility, and it prevents one single person from being able to basically rob the entire company and move the funds. And the same exact API that we use for doing multi-sig is what we use for signing the subnet auth, which, as I mentioned, whenever you create a subnet, you create a subnet auth data structure, which you have to do these you have to do these threshold control signatures, which allow you to add subnet validators and launch virtual machines onto your subnet. And so that looks like this. So first we want to create the chain, create the keychain. And a couple things to note here. I wanted to comment on, obviously, we're getting an instance of the AVM's API. This will connect it to the Json Rpc, and then we're creating an instance of a keychain. This keychain is not on the key store of the full node. This is local on your machine in AvalancheJS and in your script. The keys never need to leave your machine. Something I wanted to point out is this default local Genesis private key. We have a private key called the EWOQ key, EWOQ. Those are the first 4 characters of the CB58 encoded private key. And that has funds on the X chain, the C chain, and the P chain. It has like 300 million AVAX on the X chain, I think 50 million on the C chain, and maybe 10 or 20, I don't remember exactly, 10 or 20 million on the P chain. So if you're doing development and you need a key that has a bunch of funds already, we suggest using this. You can see it's a constant that is in AvalancheJS, and it's also in Avalanche Go. We suggest never using this, obviously, on the mainnet, because your funds will immediately get stolen because this private key is public to everybody. But I suggest not even using it on Fuji, because in theory, the workflow that you're doing is when you deploy it to Fuji, which is our test net, you want to test exactly what you're going to be deploying to the mainnet. So you don't even want to be swapping out private keys. So you could use this on the test net. It's test funds. It doesn't matter if they get taken. But just so that you're mimicking the exact workflow of what you're deploying to Fuji is going to be deployed to the mainnet, I would suggest only using this on the local machine. And then a couple other things I want to note here. You can see, so this private key is going to map to this address. We use BEC32. Avalanche is actually non-prescriptive about what address you want to use, so you can actually spin up your own virtual machine and you can use any addressing scheme you want. So for example, the Ethereum virtual machine just uses hex encoded addresses. Well, we're big advocates of BEC32. You can see that X is the chain, and then custom is the human readable prefix, 1 is the divider, and then the rest of that is the BEC32 encoded string. And then you can see that I have 3 of these keys that I'm pulling into this keychain. So the reason I wanted to do this is I kind of wanted to demonstrate that you can, with AvalancheJS, spin up a keychain, import multiple keys, and then you can do multi-sig transactions. So to create a multi-sig output, if you guys remember, I just talked about we have SecP transfer outputs, we have SecP mint outputs, we have NFT transfer outputs, we have NFT mint outputs, and they can all be plugged into a transferable output. So you can think about it like a box. You can take any one of these and just kind of stick them all in there and then pass them to any one of those transactions I showed earlier. That's how I mentioned you can transfer AVAX, transfer assets, mint new assets, create new assets, all in the same transaction. And in Avalanche world, the input minus the output equals the fee. So right above this in my script on my computer, I'm calling a Json Rpc and I'm getting a balance for these set of addresses, and then I'm just doing balance sub fee, and this fee is ultimately going to be burned, and the rest of this is going to be transferred into this multi-sig output. So we pass in the array of 3 addresses, which I just showed you in the previous slide. We have a lock time, so you can actually lock down outputs to a certain timestamp in the future, or you can just pass in 0 if you want the UTXO to be immediately spendable. That's what I'm doing in this example. So lock time is 0, and then you can have a threshold. In this case, it's 2. So what we're doing is we're creating a SecP transfer output. It's going to transfer the entire balance of these different addresses, which in this particular case is close to 300 million AVAX. And then we're going to say 2 out of these 3 addresses need to sign this transaction in order for this to be spendable. And then we take that, we wrap it in a transferable output, and then we pass that to a base transaction. And now, correspondingly, if we want to spend it, as I mentioned, there's only one type of input currently. It's a SecP transferable input. But the magic that matters is this line right here. This is the API that we use, the same API for doing multi-sig and for assigning control threshold signatures on a subnet auth. So add signature index. You give it an index. Remember, there were 3 addresses previously, and there's 0 index, so 0, 1, 2. And then you pass in an address. And what you're doing is you're saying this particular address is going to be signing the multi-signature for this particular address in the previous control signatures. And then same thing, you kind of wrap that in a transferable input and pass that to a base transaction. And then whenever we sign this transaction, we will loop over every single input because there can be multiple inputs. And for each input, we'll loop over the signature index, and we will actually sign with this address at this particular index, and then we'll pass that to a full node, and we'll let the full node do the validation. And if the full node complains and says, we were actually expecting this signature instead of this signature, it will complain and the transaction won't go through. But if you did this properly, then the full node will not complain, and it will just give you a transaction ID back, and you will have transferred the AVAX back and forth. So remember this add signature index, because we're going to look at it on this slide as well. So this is a subnet auth. So imagine I had already created a subnet, and in that subnet I had done the exact same thing as the previous slide. I had passed in 3 signatures and a threshold of 2, meaning 2 of these 3 signatures need to sign a control threshold signature anytime I want to make any changes to this subnet. In this particular case, I want to add a subnet validator to this subnet. So here you can see some kind of boilerplate stuff. We pass in a network ID. We pass in the Keychain's blockchain ID. We have a bunch of outputs and inputs. Every single transaction on Avalanche can have a 256-byte arbitrary memo string, which is kind of cool. We pass in the node ID that we want to add as a subnet validator. The start time and the end time, again, this has to be a subset of the full up to 1 year that this node is validating the the primary subnet. We pass in a weight. So as I mentioned, the weight basically just sets the statistic probability that this node will be queried every time a new block or a vertex is created. And then we pass in the subnet ID that we want to add this subnet validator to. And then lastly, once again, we call this add signature index, the exact same API for doing multi-sig, and we pass in an index and then an address. And similar to when we're doing multi-sig, when AvalancheJS goes to sign this transaction, it will loop over each of the signature indexes for this transaction, and it will sign with this address at this index, and then we'll pass this to the full node, and the full node will either complain and say, wrong number of signatures, too many or too less. It will complain and say, we were expecting this particular address to sign for this index, or it will say, all good, and it will give you back a transaction ID. Okay, so that's pretty much it. Let's see, here my summary. So again, AvalancheJS is a JavaScript library for interfacing with the Avalanche platform. It's built with TypeScript, it's very modern, it's very idiomatic, and it supports the Json Rpc, transaction serializations, and the Keychain functionality. Thank you very much. My name is Gabriel Cardona. I'm developer evangelist at Labs. I'll be around all day today as well tomorrow at the race. If anybody has any questions or wants to connect, feel free to. Here's my Twitter handle and Telegram. If you don't get to connect with me here, feel free to reach out to me on Twitter or Telegram. And then lastly, if it's as easy as me just doing this, okay, sweet. I want to give a demo really quickly. Oh, it's on my computer, darn it. I don't know if I'll be able to give a demo. It's going to be too hard for me to swap this out right now, probably. Yeah, I think it might be a little too awkward for me to give a demo. It's on my PC. So I have a great demo set up where I can show you how to launch your own subnet, add 5 subnet validators, and launch a virtual machine. It takes less than 3 minutes. I have it set up on my computer. I'm happy to show anybody who wants to see that. But Thank you so much. Thank you so much to Anthony and the team. You guys rule. See you around. Cheers.